Hello everyone. In this video, we're looking at expanding and simplifying a perfect square. For the first example that we have here is to expand and simplify the square of the binomial, the two-term expression, 3x minus 4. Method 1, what we do, we multiply the binomial by itself, as indicated by the square. If you have a squared, it means a times a. But since you have 3x minus 4 to be squared, you multiply 3x minus 4 by itself. So what we do, we multiply the first term in the first bracket, or pair of brackets, by the first term in the second pair of brackets. And that gives us 9x squared. Then we take the same first term in the first pair of brackets and multiply it by the second term in the second pair of brackets. In other words, 3x in the first bracket will multiply the 3x as well as the negative 4 in the next bracket. So when 3x multiplies negative 4, we get negative 12x. Since positive times negative is negative, 3 4s 12 times x, and so we get negative 12x. Now remember, we have no x term here. What we have is a constant. This is the only x term. And since we only have one x in the multiplication, then our solution should only have 1x. Next, we go to the negative 4 of the first bracket. And that negative 4 will multiply 3x. Negative 4 times 3x, that's also negative 12x. Then we go back to the negative 4 and we multiply by negative 4. So when we do that, we get positive 16. Notice that each term of the first bracket, or pair of brackets, will multiply each term in the second pair of brackets. Next, we simplify, bring back the quadratic term, that is the term with the square on the x. And then we will simplify the linear terms, the two terms that have an x to the first power only. This x is raised to the first power, which we do not show. This x is also raised to the first power. When a variable is raised to the first power, we do not show it. And so these two terms are like terms. And we simplify the like terms, we get negative 24x. How so? Well, a sign on the 12x, and both 12x terms are basically the same. So if the signs are the same, it tells us we must add the two numbers, 12 and 12, we get 24, and put back the x. So we're adding negative 12x to negative 12x, and we end up with negative 24x. Then we put back the plus 16. And that's the final solution for that example. In method 2, what do? Well, we want to look at a formula. When we square a binomial, that is, when we square a two-term expression, as in a plus b, what we'll do, we'll take the square of the first term, so we're going to square a, add it to the square of the second term, b. Then we'll add 2 times. So this 2 will multiply a, and then it will multiply, well, 2 will multiply a, and that product of 2 and a will multiply b. So this is not the distributive law. It will be 2 times a times b. Or we can say we multiply a by b and get ab, and then multiply that answer by 2. So this is not the distributive law. The distributive law is where we'll multiply whatever is outside the bracket by the terms within the bracket. The terms within the bracket must be adding or subtracting. But this is not the case. We have 3 terms that we're multiplying, 2, a, and b. For clarification. Now, we're squaring the difference of 2 numbers. We're squaring this binomial. And we have a subtraction instead of an addition. So for addition, we say we square the sum. For subtraction, here we're saying we're squaring the difference. But it's the same principle though. we square the first term, add it to the square of the second. So we have the same up to this point. But instead of adding 2ab, what we'll do is to subtract 2ab. So it's negative 2 times a. And the answer for negative 2 times a will multiply by b. Or we can say a times b multiplied by negative 2. So just for clarity, when we have a plus, ensure a plus goes between the sum of the squares and 2ab. And when we have a minus, ensure the minus goes between the sum of the square of the two terms and 2ab. So a plus go here because we have a plus. A minus goes here because we have a minus. All right, so what we're going to do, we're going to square the first term, and we're going to get the square of 3x, right? Added to the square of the second term, which is square of 4, minus 2. Why minus? Because we have a minus here. So we're using this example. And times the first term times the second term. Remember, the minus must only be here. Even though we can treat this 4 as negative 4, we do not do that. What we do, we just use 4 only. We do not take the minus sign with it as treated as a negative. We simply say minus 2 times 3x times 4. And simplifying that, we'll get square of 3x. So you have to ensure you put a bracket around the entire term, as in the bracket around 3x, so that we are saying 3x times 3x, which gives us 9x squared. And squaring 4, we get 16. Now, when we multiply 2 by 3, we get 6. 6 4 is 24 times x, 24x. So we're subtracting 24x. Next, we want to rearrange them. Let's put the 9x squared. Then we're going to put the x term, which is minus 24x, right after. And then put the plus 16 at the end. So notice we have the x terms first, based on the order of powers. So 9x squared minus 24x, which is to the first power, plus 16. Let's look at how we can simplify these as well. Expanding first, then simplifying. We square the first term. Now, we have to use this rule according to the instruction, okay? Using either the plus or minus, right? Squaring the sum or difference of a and b. Now, if it's the sum, we ensure that we have a plus. If it's the difference, we ensure we have a minus between the sum of the squares and 2ab. So here we have a minus. So which one we're going to use? Yes, we're going to use the difference between the square of the two terms, sum of the square of the two terms, and 2ab. So let's look at that quickly. So we're going to say square the first term, which is 7x. Notice 7x is within the two pair brackets. All right. And then we're going to say we're going to square the second term, which is squaring 3. And because we have a minus here, put the minus here. 2 times 7x times 3. This gives us what? 7x times 7x is 49x squared. Square 3 get 9. Now we're going to put back the minus sign. Since we only have one minus sign, so that will lead to being a minus. 2 7s, 14 times 3, 42. Times x, 42x, so minus 42x. Then we can rearrange that according to the x's. And so this will be our final answer. Now next we square the 1. And then we're going to square the next term, which is 6x. So add it to square of 6x. Then because we have a negative or minus in between, we put minus 2 times the 1 times the 6x. Simplifying, square of 1 is 1. Square of 6x is 36x squared, because 6 is 36xx, give you x squared. And then we get a 12x here. I'll show you see how. And then we're going to get 36x squared, put the minus 12x, and put the plus 1. Okay, the signs remain the same in front that we are seeing before. The 36x squared should be positive. Before the 12x should be a minus, and that's the case here. Before the 1, because it now is now at the end, we have to make sure we separate the 1 with the other terms by putting the sign in front of it. And the sign we put in front of it is based on the sign of 1. 1 is positive, so plus goes there. All right, that's the answer. For number 3, we square x added to the square of p minus 2 times x times p. All right, and then that's the solution. Then look at number 4. This time we have a plus. So what we're going to use here, are we going to use a plus or a minus? That's correct. If it's a plus, we use a plus. If it's a minus, we use a minus between the sum of the squares and 2ab. So this time we're going to use a plus. So we square the 6x, add it to the square root of 5, then plus 2 times 6x times 5. And tidying this up, we get the solution. Remember, we want to have the order correct, as in this, the quadratic term first, as in the x squared term, then the linear term, as in the x term, and a constant term, as in the 25. That's it for that one. Next, let's look at this one. We square the 1, add it to the square of 4x, plus, since we have a plus here, plus 2 times the first times the second term. Tidying this up, we'll get the solution there. So we're going to put it in the order again, the x squared term, the quadratic term, then the linear, then the constant. Any question? Post in the comments. Then last, we square the first, add it to the square of the second, plus, again, because we have a plus, we use plus 2, multiplied by the first times the second term. Simplifying, we get a solution. And if we want, we can leave our solution as this, but we can actually put this term, as we've been doing all along, put the linear term. This is a linear term, it's just that 2p will consider the coefficient and the x. So this is an x term, put x term after. And then we put the p term at the end. All right, now we want to illustrate exactly how we expand and simplify a perfect square. So let's illustrate that. So here we have a perfect square, as in a square, meaning that the sides are all the same measure. So let's say we take that side to be 13 centimeters, this one. Then this adjacent side must be what as well? If it's a square, the same, yeah. And the area will be what? Multiplying the two adjacent sides, the length by the width. Now, which one is length, which one is width? Typically, the length is the longest side. But you see, a square is a special rectangle where the width and length are the same measure. So we can just simply say length times length. And that will give us our answer. So 13 times 13, or 13 squared, is 169 square centimeters. Let's make a replica of this square. And what we're going to do, we're going to take only a portion of the 13. Let's take 5 units there. We'll take 5 units for that adjacent side, and for this, the other side, to this adjacent side here, will be also 5. And so the remaining portion must be what? If the entire side here is 13, and this side is 5, and this adjacent side is also 5, what will be the remaining length of both sides? Must be the difference between 13 and 5, which is 8. All right, so let's divide up this square into 4 parts then. All right, according to the measurements that we have. And so we can label each part or each rectangle as A, B, C, and D. Now, let's find the area of each rectangle, then add them up. And obviously, we should get the same area. Combining these rectangles, we should have the same area, correct? Right. So let's find the area of shape A. Shape A, now obviously this rectangle is a special one, which is that the lengths of the sides, the two adjacent sides, are the same. So the length and width are the same, so we can just simply say length squared, or 5 squared, which is 5 times 5, which is 25 square centimeters. B, length is 8, and the width here, opposite to this side, is the same, so this is 5. 8 5s, 40, so that's 40 square centimeters. For rectangle C, this is going to be 8 centimeters by 5 centimeters, length by width. Remember, the length is the longest side, no matter where Okay, so this is the length for this rectangle, and this is the length for this rectangle. Choose up the longest side as the length, and so the shortest side will be the width. So 8 by 5 would be 40 square centimeters. Now the length and the width is the same for this rectangle, and so we just simply say length by length, or length squared, and the length is 8, so that's 8 squared, or 8 times 8 for shape D, which is actually a square, and that's 64 square centimeters. Now when we add up those 4 areas, we add the areas for the 4 rectangles, we should get 169 square centimeters. Okay, because 25 plus 40, 65 plus 40, 105 plus 64, 169 square centimeters. Now, why did I do all that? Well, it's just to illustrate this point. What I'm going to do here, I'm going to remove the 5 and put it as unknown. Let's use X to represent that. And the 8, let's take off the centimeters from it. So we have X as the length of rectangle or square A. And this side is also going to be X as well. So the length of the entire side of this square, the length of this side will be what? This measurement plus this measurement. This measurement is X, this measurement 8. So the length of this side is X plus 8. And the length of this side is also X plus 8. So to find the area for shape A, which is a square, it's going to be length squared, or X times X, or X squared. For shape B, is going to be 8, the length, by the width, which is X. So 8 by X, that's 8X. That's the area for shape B. For shape C, it's going to be length by width. So it's 8 by X as well. For shape C, which is a rectangle, which gives us 8X. And for shape D, it's going to be what? 8 by 8. Remember, this length is 8. This length is also 8. Look at the opposite side of B. 8. So this must be 8 as well. And so 8 by 8 is 64. Now when you add these areas together, X squared can be added to these because these are X terms. It's an X squared term. So these are unlike terms. It's a quadratic term because the power is 2. These are linear terms because the power on the X would be 1. So only the linear terms could be added to are combined to get 16X. And 64. Let's bring that down as well. So it's X squared, this area, plus the sum of these two areas being 16X plus 64. We can't add these, as in we cannot put a single number because these are all unlike terms. Now let us look at something else. Recognize that this side here, the length of this side is X plus 8. So when I multiply the length of this side, which is X plus 8, by X plus 8, I should get what? When you multiply A by A, what do you get? A squared, right? When you multiply B by B, what do you get? B squared. So when I multiply X plus 8 by itself, I should get the square of X plus 8, or X plus 8 to be squared. So this is what we call the perfect square, because when we multiply X plus 8 by X plus 8, we're finding the area of a square. So this is basically the area of a square. A side of X plus 8 in length multiplied by itself, length by length, since it's a square. And notice that the answer we got down here when we actually divide up the square into different rectangles. Well, since we were looking at X plus 8 times X plus 8, we should get back the same answer as when we divide up this square into different parts and add the areas. So let's look at this. Let's see if we can actually go from this to get this answer down here. Well, let's do that. Recognize that when we multiply X plus 8 by itself, we simply say X times X. So let's do that. X times X, that gives us X squared. And then X times 8, that gives us 8X. We've exhausted the X by multiplying by X in the next bracket and 8 in the next bracket, pair brackets. So we're going to now multiply 8, multiply from 8 to the two terms in the other bracket, pair brackets. So 8 times X gives us 8X, and 8 times 8 give us 64. And of course, only the two middle terms are like terms. So about the X squared term, 8x plus 8x is 16x. Go back to 64. And if you notice that that answer that we have here is the same as this one down here. See, so when you're doing this, or expanding a perfect square and simplifying, is basically taking a perfect square, divide it up into rectangles, and finding each area to get this answer. But this is much a faster way of doing it. All right, hope this video was helpful. Now please remember to subscribe.